Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So today we proceed with the last topic of this subject, that is multiplexing. So today you will learn about the process of multiplexing, start of multiplexing, and application of multiplexing. As introduction, multiplexing is the process of transmitting two or more signals simultaneously, as known as multiplexing. So before this, you have learned about how to transfer one signal, transmit and receive the signal. That is either the analog or digital. But multiplexing is the process of transmit two or more signals. That is more than one signal. So the main objective of this system is to increase the capacity of transmission. So before this you only send one. So for multiplexing you can send more than one. So it's increase the capacity. So there are three multiplexing method, that is frequency, time and space. So the frequency is called as frequency division multiplexing, and the second one is time division multiplexing, and the third one is space division multiplexing. Okay, we proceed with the first method, that is frequency division multiplexing, FDM. So FDM system can be used in both analog and digital system, and FDM use a different carrier. Okay, for this one is frequency division multiplexing. That means it is different carrier. So we have here the spectrum. So we have FC2 here and FC1. So each of the signal will send based on the carrier. That is, we have different carrier frequency. Okay, for example, this is the block diagram FDM for three sub-carrier frequency. So we have first signal, second signal, and third signal. And then this signal will multiply with different frequency carrier. For example, for FC1, it's multiplied with 1 kilohertz, and then FC2 multiplied by 2 kilohertz, and FC3 multiplied by 3 kilohertz. So different carrier signal. At each signal, we then pass through the BPF with bandwidth of FC plus FM or FC plus, minus FM. So this one, it will have the band pass filter. So it's only allow the signal with the FC plus FM and FC minus FM. And the output of BPF will then be either lower side band LSB or upper side band. So this is the output, either upper side band or lower side band. And the output from each filter will be multiplexed together. Okay, this one we have the first signal go through the bandpass filter, second signal and third signal, and then it will multiplex together. It will multiply together to get as the signal of FDM. In FDM process, each information signal is multiplied by different subcarrier frequency. Okay, as I explained before, this one FC1, FC2 and FC3 have different frequency based on the carrier. So for VC1, for VM1 and so on. And the output of the multiplier will be a double sideband suppressor because we have the signal like this. Okay, and the spectrum for the FDM for the three subcarrier is like this. So we have we have FC1, FC2 and FC3, and these three frequency is referred to the channel 1, channel 2 and channel 3, and the bandwidth of FDM depend on the number of subcarrier used. Okay, for example here it has 3 subcarrier, but it can be more. It can be 2, 3, 4, 5, and so on. And the bandwidth is from here to here is depend on the how many subcarrier. And for n subcarrier, for example, here is 3. The bandwidth of FDM is 3 FM. But for if the number of subcarrier is 7, it is 7 FM. Okay, let's look at this example. For information signal FM1, FM2, FM3 and FM4 with frequency range of 10 Hz to the 4 kHz were transmitting using AM double sideband FDM system. The center frequency at FO for this FDM system is 90 MHz. So there are two questions. Determines the minimum subcarrier frequency for each information signal, and then the second is calculate the bandwidth for the system. Okay, we have like before this it is 3, so this one is 4. This one means 4 channel. So we have 1, 2, 3, 4. So this is for the subchannel V1, V2, V3 and V4. And in the range of frequency is the frequency from 10 Hz to 4 kHz. And the center here is 900 MHz. So determine the minimum subcarrier frequency. So we want this, where is this value. Okay, the example. So for okay, let's try this example. For information signal VM1, VM2 and VM3 and VM4 with frequency range 10 Hz to 4 kHz were transmitted using AM double sideband FDM system. The center frequency F0 for this FDM system is 900 MHz. Determines the minimum subcarrier frequency for each information signal. And second is calculate the bandwidth for the system. Okay, the system is a system FDM and subcarrier depends on, this one is have four signals, so they will have 4 subcarrier or 4 channel. Okay, the 4 channel is like this, and then we have VM1, VM2, VM3 and VM4 here. And the center, this is the F0. F0 is equal 900 megahertz. Okay, and then find the minimum subcarrier. Okay, frequency for each information signal. Okay, this one is have 4 information signal, and this question want to have the value of this, the minimum frequency of each subcarrier signal, and calculate the bandwidth. Bandwidth is from here to this one. This is the bandwidth. Okay, so how to solve this? Okay, minimum subcarrier frequency depend on the minimum bandwidth of the sample signal, and the minimum bandwidth of each information signal is okay, we have the F max is this one. Okay, because the signal here this is FM. FM maximum is 4 kHz and minimum 10 Hz. So the value here is bandwidth is 2 Fmax. Fmax is FM max. FM max is 4 kHz and the bandwidth is 8 kHz. So the bandwidth for this signal is 8 kHz. And then we have F0 is 900 megahertz. And okay, this one is because from the question is informed that the 900 megahertz is the center frequency of the system. Okay, this one is all this is system. So the center is here. And at each system, we have the carrier frequency. We have the center of carrier frequency, and this channel go through the band pass filter. And the band pass filter will go through the FC minus FM and FC plus FM. So each here is FC1 minus FM, and then the upper is FC1 plus FM. So same here, FC2 minus FM, FC2 plus FM, and then the FC1, okay, for example, you look here, FC1 plus FM, same value with FC2 minus FM. Okay, same here. So we already know that FC2 plus FM equal to 900 megahertz. Okay, so from here, when you can solve either from this one, for example, FC2 plus FM equal to 900 megahertz, and then FM is the 4 kilohertz. Okay, so FC2 equal 900 megahertz minus FM is 4 kilohertz. Okay, and you solve the FC2 first and then get the another, or another method you can from here. Okay, this is FC. Okay, this one is F0, and then we have the another method is you solve is based on the F0, so you will get the equation like this, but it's similar with the previous as I explained here. Okay, and the second question is the bandwidth of the system. Okay, this one is the bandwidth of the signal. Okay, this one is bandwidth of each. Each here is the bandwidth 2 Fmax, and then if we want to get this bandwidth, so we need to multiply the number of channel multiplied by bandwidth of each channel. Okay, so you will get the bandwidth is 32 kilohertz. Okay, the second method of multiplexing is time division multiplexing. Okay, before this, the FDM frequency of each signal is different, but for time division multiplexing, the time of the signal is different. So for time division multiplexing is only used for digital system, and the TDM system use a different time slot for each user, but with the same frequency. So the frequency is same, but the time is different. Okay, like this. So we have same frequency but different time. Okay, there are two types of time division multiplexing. There is TDM-PAM and TDM-PCM. So for the TDM-PAM, the input signal is PAM. Okay, just remember what PAM. PAM is if you have analog signal like this and it's become based on the amplitude. So this A refer to amplitude. This one pulse amplitude modulation. So it's like this, and PCM is the coding 0, 1, something. So TDM PCM can also receive in the form of PAM signal, PAM sample. However, this PAM sample need to be changed to digital form by using quantizer and encoded or analog to digital converter after sample by the commutator before transmitting on the line. So this means we also can use the this TDM PCM also can use the signal from PAM but need to quantize and encode. Okay, this is the okay. Let's proceed with the process of multiplexing TDM. So in TDM, so we have the signal VM1, VM2 and VM3, and this process is in this sample is the PAM signal. This PAM signal will be sampled by the commutator, where the commutator is combine all this with different time, and the information will be convert into digital. So okay, this one we have VM1, VM2 and VM3, and these three sample uh, will be in the same frame. So this one is one frame, so this one is another frame. So all sample bit for one complete cycle of the commutator is known as frame. So this one will be combined by the commutator and then convert into the digital, and it will categorize by one frame. So this is one frame, second frame, and so on. Okay, there are many parameters of times division multiplexing. Okay, so for example with this system, we have the sampling frequency 8 kilohertz, fs 8 kilohertz and code using 8 bit per sample. Okay, 8 bit per samples. Okay, one of the okay, there are several parameters that you need to know in the TDM. Okay, for the first one is period for time slot. Okay, period for time slot means period for channel. Okay, we have the uh, channel 1, channel 2 and channel 3 that are same with different time but same frequency. So frequency same, times not same. So the given is information signal is sampled at sampling frequency 8 kilohertz. Okay, this 8 kilohertz is the frequency of the frame. Okay, this is a frame. Frequency for the frame. So, okay, this is the frequency of frame. So, to get the period, it is 1 over f. Okay, this is frame. Okay, for C1, C2, C3, this is one frame. One frame have 3 channels. So, the formula for period for channel, each channel is period sample or period frame over 3. For the period 3, period for the frame is 1 over f. The f is 8 kilohertz. So 1 over 8 kilohertz over 3. So you will get the period for channel is 41.67 millisecond. And then the second parameter is number of bits per channel. Okay, from the given information, coded using 8 bit per sample. Okay, this is a bit tricky because for this one, the sampling frequency refer to F frame, but bit per sample refer bit per channel. So sample here is channel. So number of bit for each channel mean 8 bit. So the third parameter is bit rate for each channel. Okay, bit rate is the bit rate for each channel is how many bits per second for each channel. Okay, for this one, okay, we have C1, C2 and C3. Okay, as I mentioned before, um, for the TDM, F is same for all channel but time is different. So for this one, T frame here, okay, this F frame, sampling frequency 8 kilohertz is F frame, also F channel, because the frequency for frame and channel is same for this system. So this one, the bit rate for each channel is n times n is bit per channel times the fn is frequency per channel also. Okay, so for this one, bit per channel is 8, so 8 bit times, okay, frequency here is 8 kilohertz, but also we can write this by 8 per second. So the 8 kilo. 8 kilo per second. So that's why we get 64 kb is kilobit per second, p per second. So bit rate for each channel is 64 kilobit per second. Okay, the fourth parameter is period for one frame. Okay, for here, T channel is period of this each channel from here to here. But for period for frame is the period from here to here. That is consists of all three channels. So the formula is number of channel times period of channel. So period of channel we already calculate 41. So 41.67 times 3. 3 is number of channel per one frame. So period for one frame is 125 microsecond. A number of bit per frame. Number of bit for one frame. Okay, one frame for 3 channel. So for one channel we have 8 bit here. And there are 3 channels, so number of bit for one frame is 24 bits. And the bit rate for each frame is number of channel times 64 kilobit per second from here. Okay, because we want to know how many bits for each frame. So each frame has 64, so you need to times 3 to get the 182 kilobit per second for one frame. This is uh, this is 5, 6, and the last one is minimum bandwidth. Minimum bandwidth is the bit rate for each frame over 2. So the minimum bandwidth is 96 kilohertz. Okay, the third multiplexing is space division multiplexing, SDM. As with other multiplexing system, this system also aims to increase the capacity of users and reduce the effects of fading away that result from various routes. SDM is performed by using different transistors for each user. Okay, nowadays these techniques can implement using a smart antenna. So there are two methods that you can use. That is different channel or different cable, and then another one is smart antenna. Okay, as I figure here, there's two. There is multi cable and smart antenna. Okay, for the multi cable, this is we have many transmitter and is combined together using the multiple cable, transmission cable, and then you will get many signal can transfer in one times. Okay, for the smart antenna, digital signal processing (DSP) here. Okay, DSP is digital signal processing is required to separate the information signal which are divided between the send and receive. So there are DSP in the transmission medium of the transmitter and receiver. Okay, advantages and disadvantages of SDM. So the advantage is the channel can still operate even though there is a fault in one of the cable, and it easier maintenance works. And the disadvantage of SDM is increase the cable cost and size of the cable become bigger and entangled. Okay, the application of multiplexing. A multiplexer is used in numerous applications like transmitting using single line. In communication work, a multiplexer is used in communication system which has transmission system and also communication network. A multiplexer is used to increase the efficiency of the communication system by allowing the transmitter of data as audio and video data from different channels via cable and single line. And for the computer memory, a multiplexer is used in computer memory to keep up a vast amount of memory in the computer. And for telephone network, a multiplexer is used in telephone network to integrate the multiple audio signal on a single line of transmission. Okay, we go further for the application of FDM, frequency division multiplexing. Okay, one example of application using FDM is the L carrier line telephone system by AT&T in US and AT&T. Okay, so this is the hierarchy of ITUT FDM. So we have channel, group, super group, master group, and jumbo group. Okay, this is number of channel. For channel, okay, only one channel. And group, we have uh, 12 channel per group. And for the super group, okay, this is the hierarchy. Okay, okay, the hierarchy of the FDM telephony system used in Malaysia are like this. That we have a channel with the telephone signal with the bandwidth of 4 kHz, and the basic group consists of 12 telephone channel. So this one from 1 to 12 will be multiplexed together into the basic group. And basic group we have okay, basic group we have 12 channel, and then super group have carry the 60 telephone channel, which has 5. Okay, for the super group we have 5 basic group, so 5 times 12 we have 60 telephone channel in the super group, and the bandwidth is 240 kHz. And then 5 super group combined together into master group. We so 60 times 5 we have 300 telephone channel with the bandwidth of 1.2 MHz. And for super master group, it's include the 900 telephone channel, because for the super master group have 3 master group, so 3 times 300 we have 6 sorry 900 telephone channel with the bandwidth of 3.6 MHz. So 900 telephone channel were transmitted using one coaxial cable with bandwidth of 4 MHz. So in the one telephone channel, there are 900 telephone channel for one cable. Okay. Okay, next one is for the FDM, frequency division multiplexer. An application of TDM is the telephone in US and European. Okay. Okay, we have looked for the FDM application. So another application is application of TDM, times division multiplication, and there are two standard in telephone system that use PCM TDM. That is T line by AT&T in US and E line by CEPT in European countries. Telephone system in Malaysia use the standard fixed by CEPT. And the transmission process of TDM signal was conducted by using 32 time channel for E1 line. Okay, each channel consists of 8-bit PCM signal using Mueller non-uniform quantization. Okay, for this one frame, there are 32 channel. There is 30 is voice and 2 channel for synchronizing and signaling. So the frame period T period is 125 microsecond. So the 0 bit usually for the synchronization, and then 1 to 15 is for voice channel, and then 16 the signaling, and then continue with the voice signal. Okay, in the CEPT system, a frame contains 255 bits. Okay, because one channel have 8 bit and there are 32 channels. So 8 times 32 we get 256 bit per frame. Okay, so how to calculate the bit rate? Okay, the bit rate formula is T period over total bit. Okay, from previous, the T period is 125 microsecond. So 125 microsecond over the total bits is 256, and then you will get the, okay, this is for the bit period, and the bit rate is 1 over T. So the bit rate is 2.049 megabits per second. So bit rate 2.08 megabit per second represent the bit rate for E1 line in CEPT system. The bit rate increased through multiplexing process from E1 line to E2 line and so on. Okay, then each frame is transmitted in a group of multi-frame that contain 15 frames from 0 to there is 16 frames from 0 to 15. In this system, 500 multi-frame is 8,000 over 16 is transmitted every second. Okay, the figure show the frame arrangement for a multi-frame. For example, for frame 0, the time slot 0 and 16 will be transmitted, and so on. So the line hierarchy for the CEPT telephone system, 30 voice channel and 2 signaling channel will be multiplexed together to get the E1 line. That is 2.048 megabits per second. Because we have in E1 line there are 32 channel. So this is the data rate, and then for E1 were next multiplexed to become E2 line with the data rate of 8.448 megabits per second, and then another for E2 line were multiplexed become E3 line. Okay, and so on. Okay, this is the example for the PCM TDM. Okay, a PCM TDM communication system contains 30 voice channel and 2 control channels. The information data rate is 64 kilobit per second for each channel. The audio channel represents information signal that is quantized to 256 levels, determines the bit rate for each frame FB and bit period TB, and the third one is the maximum audio frequency that can be transmitted. Okay, given here the one frame have 32 time slot, 32 time slot here based on the 30 plus 2, and then so the bit per second is 64 kilobit per second for each channel. 64 kilobit per second for each channel. So for bit rate for one frame is 32 times 64. So you will get 2.048 megabit per second. And then the bit period is 1 over frequency frame. So 1 over 2.048 is 0.488 microsecond. And the third one is the maximum audio frequency. Okay, sampling frequency for an audio signal is same as the sampling frequency used by the commutator. Given the sampling period for one frame is 125 microsecond as I calculated before, therefore the sampling frequency is 8 kilohertz because 1 over 125 microsecond you will get the 8 kilohertz. The 8 kilohertz is the sampling frequency. From the Nyquist formula, the frequency for the sampling is 2f max. So to get the maximum audio frequency, it is the f max. You need to calculate the fm. So fm is fn over 2. So fn here, sampling frequency or Nyquist frequency is 8 kilohertz. So 8 kilohertz over 2, the answer is 4 kilohertz. Okay, for example 3, design a TDM communication system that can accommodate 11 information signal with the following characteristic. Information 1, analog signal. Okay, until information 3, it is analog signal. And information 4 until 11 is the digital signal synchronized at a bit rate of 7,200 bits per second. And a 4-bit analog to digital converter is used. Okay, the solution. Okay, for TDM, this is the block diagram of the process of the TDM. We have the commutator is for the PAM, for the analog. So from the question, we have three analog signal, and then 4 to 11 is digital signal. So for the analog signal, need to use the commutator. At the 4 kilohertz is given. Okay, to get this frequency, we need to calculate the sampling frequency for each channel first. For each channel is have different frequency maximum. So for the first signal, the frequency sampling is 2 times 2 kilohertz. That is 400 hertz or 400 sampling per second. And then the second is 2 times for 800 sample per second, and the third one is 2 times 2 kilohertz for 4,000 sample per second. Therefore, the maximum time for the frame is 0.25 millisecond. Follow the lowest Nyquist. So this one 4 kilohertz is 1 over 0.25 millisecond. Okay, and then that one is for the analog signal. Okay, this one is the for the analog. For the times TDM is need to convert into digital. So it convert by using 4-bit AD with 16 kilo sample per second. 16 kilo sample is by adding all the sample, you will get 16 kilo sample per second. And for the digital signal, it will use pulse stuffing with the bit rate of 7,200 bit per second. Use 4-bit AD converter for the analog. Okay, so this is the answer for question 3. Okay, that's all for today. Okay, I will discuss more on the final exam in the WhatsApp group. Okay, thank you.